Hey there, space explorers! Are you ready to embark on an incredible journey through the cosmos? It's your old pal Bill Nye here to talk about something truly awe-inspiring, the life cycle of our very own star, the Sun. This isn't just any star, it's the one that makes life on Earth possible. Now you might think of the Sun as this constant ball of fire in the sky, and you're not wrong, but there's so much more to it than meets the eye. But even stars have a lifespan, and our Sun is no different. It's been shining for about 4.6 billion years and has a fascinating story to tell. Right now, our Sun is happily buzzing along in its main sequence, which is like the prime of its life. It's stable, burning hydrogen into helium at its core. It's fusing hydrogen into helium, releasing the energy that bathes our planet in light and warmth. This process is what keeps our days bright and our nights just a little bit warmer. But don't worry, this won't last forever. The Sun has enough fuel to keep burning for another 5 billion years or so. Billions of years from now, the Sun will embark on an incredible transformation, eventually becoming something called a white dwarf. This is a dramatic change that will mark the end of its life cycle. Think of it like a caterpillar turning into a butterfly, but on a cosmic scale. The Sun will expand into a red giant, shedding its outer layers before shrinking down to a white dwarf. It's a journey filled with dramatic changes, and we're about to break it all down for you. From the main sequence to the red giant phase, and finally to the white dwarf stage, each step is more fascinating than the last. So buckle up, because we're about to dive into the fascinating future of our Sun. Imagine witnessing these transformations from a safe distance. It's the ultimate cosmic show. Get ready to have your mind blown as we explore the incredible stages of the Sun's transformation. Each phase is a testament to the dynamic and ever-changing nature of our universe. From a giant red star to a tiny, dense white dwarf, the future of our Sun is a story you won't want to miss. Stay tuned as we unravel the mysteries of our star's grand journey. Okay, picture this. Billions of years from now, the Sun starts to run out of its hydrogen fuel in its core. This is where things get interesting. Without hydrogen to fuse, the core starts to shrink under its own gravity. But here's the twist. As the core shrinks, it gets hotter and hotter. This intense heat causes the Sun's outer layers to expand outward, like a balloon inflating. We're talking way bigger than its current size. The Sun will swell up so much that it will engulf the orbits of Mercury and Venus, maybe even Earth. Talk about a close shave. At this point, the Sun will be a red giant, a massive star with a cooler surface temperature, hence the reddish hue. It's a dramatic makeover for our Sun, but it's just the beginning of the story. Hold on tight, because the transformation from a red giant is about to get even more spectacular. So, we've got this giant red Sun, right? Well, as the Sun's core continues to contract, it heats up even more. This intense heat eventually reaches the outer layers, causing them to become unstable. Think of it like a boiling pot overflowing. These outer layers are then gently puffed off into space, creating a stunning cosmic display called a planetary nebula. Now don't let the name fool you, it has nothing to do with planets. Early astronomers thought these glowing clouds of gas looked like planets, but we now know they're actually the remnants of dying stars. These planetary nebulas come in all sorts of shapes and sizes, from glowing rings to intricate, colorful clouds. They're like giant cosmic works of art, and our Sun will create one too. But what happens to the Sun's core while all this is going on? Well, that's where the real magic happens. Remember that super hot, super dense core we talked about? Well, once the Sun sheds its outer layers, that core is left behind, and it's no longer a giant. Instead, it's shrunk down to about the size of Earth. Can you believe that? This tiny, incredibly dense object is what we call a white dwarf. It's essentially the leftover embers of our once mighty Sun. Don't let its small size fool you though. White dwarfs are incredibly hot. With surface temperatures reaching tens of thousands of degrees, they glow with a white-hot intensity, hence the name. But here's the thing. A white dwarf isn't producing any new energy. It's simply radiating away the heat it built up over billions of years. Like a slowly cooling ember in a fireplace. Now, you might be wondering, how can something so small be so incredibly dense? Well, that's where things get really mind-boggling. Imagine taking all the mass of our Sun, which is about 333,000 times the mass of Earth, and squeezing it down to the size of our planet. That's the kind of density we're talking about with a white dwarf. To give you an idea of just how extreme this is, a teaspoonful of white dwarf material would weigh about as much as an elephant. That's because the atoms inside a white dwarf are packed together incredibly tightly. This extreme density is what gives white dwarfs their incredible gravitational pull, even though they're relatively small. It's like squeezing all the juice out of a grapefruit and ending up with a tiny, super concentrated shot of grapefruitness. But what does all this mean for the planets in our solar system? Let's just say things are about to get a little shaky. Section 6. The fate of our world. As the sun expands into a red giant, the inner planets, including Mercury, Venus, and yes, even Earth, are in for a rough ride. Remember how the sun will swell up to engulf those planets? Well, that's not good news for life as we know it. The intense heat from the expanding sun will boil away Earth's oceans, turning our planet into a scorching, lifeless desert. It's not a pretty picture, but it's important to remember that this won't happen for billions of years. By then, who knows what incredible technologies or even other planets humans might be exploring. Still, it's a stark reminder of the power of stellar evolution and the ever-changing nature of our universe. But what about the outer planets? Well, they're in for some changes too, but they might just come out the other side. Section 7. The outer planets' new reality. While the inner planets face a fiery fate, the outer gas giants like Jupiter, Saturn, Uranus, and Neptune will experience a different kind of transformation. As the sun loses mass during its red giant phase, its gravitational pull on the outer planets will weaken. This means their orbits will expand, taking them farther away from the sun. They'll be like kids on a playground roundabout that's suddenly spinning a little slower. While the outer planets might be farther away from the sun's heat, they'll still be bathed in the eerie glow of the white dwarf. It's a whole new era for our solar system, with the once mighty sun reduced to a faint ember in the cosmic night. But what about the white dwarf itself? What's its ultimate fate? Section 8. Fading to black, the sun's final bow. Even though white dwarfs are incredibly hot, they're not generating any new energy. These stellar remnants are the cores of stars that have exhausted their nuclear fuel and shed their outer layers. Over billions and billions of years, they slowly radiate away their heat, like a dying ember in a fireplace. This process is incredibly slow, taking longer than the current age of the universe. As they cool down, they become dimmer and dimmer, eventually fading from view. The light they once emitted diminishes until they are no longer visible to the naked eye. The final stage of a white dwarf is thought to be a black dwarf, a cold, dark object no longer emitting any significant heat or light. This theoretical stage represents the ultimate fate of these stars. It's the end of the line for our sun, but it's also a natural part of the stellar life cycle. Stars are born, they live, and they die, each stage contributing to the cosmic tapestry. Think of it like the final page in a really, really long book. Each chapter has its own story, and the end is just a part of the narrative. The story might be over, but it was one heck of a ride. From the sun's fiery birth to its serene end, every moment has been a spectacle of cosmic proportions. Now you might be thinking, Bill, this is all fascinating, but what's the point? Why should we care about the sun's distant future? Why should we care about what happens to the sun billions of years from now? Understanding the sun's life cycle helps us comprehend the broader workings of the universe. Well, I'm glad you asked. By studying the sun, we learn about the life cycles of other stars, the formation of planets, and even the potential for life elsewhere in the cosmos. Section 9. A glimpse into the cosmos. Understanding the life cycle of stars like our sun isn't just about predicting the future of our solar system. It's a journey into the very fabric of the universe, a quest to comprehend the forces that shape everything we see in the night sky. It's about unraveling the mysteries of the universe and our place in it. Each star, each galaxy, each nebula holds secrets that can tell us more about where we come from and where we might be headed. By studying how stars are born, live, and die, we gain a deeper understanding of the fundamental laws of physics that govern the cosmos. These laws are the same ones that govern our own planet and our very existence. It's like piecing together a giant cosmic jigsaw puzzle, and every new discovery brings us closer to understanding the bigger picture. Each piece of data, each observation, adds to our knowledge and helps us see the universe in a new light. So the next time you look up at the sun, remember that it's not just a ball of fire in the sky. It's a dynamic, evolving star with a story to tell, a story that stretches billions of years into the past and billions of years into the future. It's a dynamic, evolving star with a story to tell, a story that stretches billions of years into the past and billions of years into the future. The sun's journey is a testament to the incredible processes that govern the universe, and who knows, maybe by understanding the sun's journey, we'll unlock the secrets to exploring even more distant stars and galaxies in the vast universe we call home. The possibilities are endless, and the adventure is just beginning. Keep exploring, keep asking questions, and never stop being curious about the universe around us. Curiosity is the driving force behind every great discovery, and the cosmos is full of wonders waiting to be uncovered. This is Bill Nye signing off. Remember, the universe is vast and full of mysteries. Stay curious and keep looking up.